This is going to be the walkthrough for summative assignment check-in number 2. So for this one, I'm going to start off by actually reading the directions for this check-in. Typically, you can just go right to the template and that will have you answer all the questions, but I believe the directions here actually give a little additional context that you wouldn't get just from going right to the template. Now in this check-in, the main thing that we are trying to have you learn to do is develop hypotheses and use pivot tables. So if you go through the directions, one of the things that you'll see actually at the end is sort of a summary of how you're going to go about creating the pivot tables. So the very last bullet point says, first use a single tabulation, look at the mean of hospital days, and then try to think of possible two-way cross tabulations. So for the single tabulation, what that means is we are going to look at just our variable of interest. When we develop the hypotheses that you'll need to develop for this assignment, each hypothesis is going to be comprised of two variables, a variable of interest, which you'll be identifying here, and an explanatory variable. The variable of interest is basically the outcome variable. You're looking for one variable to see if it has an effect on another variable. The variable being affected is your outcome. Now, in your final paper, you are going to be looking at different ways that we can potentially reduce costs, if assuming you're taking the role of a hospital administrator. But there isn't a direct variable in the data set for cost, so we're going to be using hospital days per decedent as a proxy for cost. So your outcome variable for all your analyses should be hospital days per decedent, and that's going to be consistent for all your check-ins. Now, just like with the first check-in, whatever hypotheses you make, and we're going to get into more detail in that in a second, and whatever pivot tables you create, whatever analyses you run for the check-ins, you're not married to in the paper, but I do strongly encourage you to get used to using hospital days per decedent as your outcome variable for everything, just because that's what you're going to be using in the paper, and I find when people try to do other things with it, they just get confused later on when they have to go back and use the hospital days per decedent. So for the first single tabulation, so we're going to do the first tabulation before we get into the actual hypotheses. That one we're going to be doing on our outcome variable, which again should be hospital days per decedent. If you maybe are more advanced and you've taken some stats classes before and you want to write and you kind of know what you're going to do and you want to write your paper a little bit differently, you're welcome to talk to your professor about that and use a different outcome variable. But I just strongly encourage you just to use hospital days per decedent. It'll make your life so much easier. So we're going to go to So we're going to take the hospital days per decedent field here, and we are going to just click on it to check it, or you can drag it into values. Though if you do both, it'll appear twice. Now, under values, we see here it says sum of hospital days per, it doesn't have the full name, but hospital days per decedent. We're going to click the little arrow to have a drop down, go to value field settings, and then we're going to change sum here to average. What this is showing you, here I'll zoom in so you can see a little bit better. This is showing you the average hospital days per decedent for the entire data set. The reason I did that is because in the directions it said first look at the mean of hospital days. That's what I'm doing here. I'm making a pivot table where I include average hospital days per decedent, just to show you that average before we get into the hypotheses. Okay, so now we're going to get into the piece that is in the template here. And that is making hypotheses and making pivot tables to check those hypotheses. So for each hypothesis, you're going to have, like I said before, a variable of interest and an explanatory variable. And you want to predict how one variable relates to the other. So for example, I'm just gonna take two random variables in this data set to give you guys an example. And it is your call if you want to do that or do something else. I don't have a healthcare background myself, so I don't really know which variables you would predict would go together. So this isn't, so me using these as examples doesn't necessarily mean that they make sense. Okay. So as an example, I'm gonna look through the data set and I'm gonna see, okay, what are some of the variables here? What do I think might be related to each other? And let's say, for example, my first hypothesis, I'm gonna say that there is a relationship between state and hospital days per decedent. Remember, in the outcome variable of all your hypotheses, I highly recommend for it to be hospital days per decedent. So I might say, in my hypothesis, I might say that different states have different average hospital days per decedent. I might get more specific and say, California, I predict will have the highest hospital days per decedent. So I'm going to highlight data. In my case, the main thing is you need to make sure you highlight the data that includes the columns you're interested in. You can either just highlight the whole data set, or you can start at one variable and then go over to the other. As long as the variables that you're using are included. And you can do this multiple times for different pivot tables, or you can highlight the whole data set and do all your pivot tables in one go. So I'm going to click Insert. I was already there. I'm going to click Insert, Pivot Table. Click OK. Now I'm going to put my explanatory variable in the rows and my outcome variable in the values. And this is going to be the case for all your hypotheses. So I'm going to take state and I'm going to drag it into rows. And I'm going to take hospital days per decedent and drag it into values. Now, when you drag your outcome variable into values, which again, generally speaking, should be hospital days per decedent, you'll notice here it defaults to showing the sum of that variable. But we really are generally going to be more interested in the average than the sum for the type of questions that we're asking. So I'm going to click just like we did when we had the single tabulation, I'm going to click the little drop down arrow here, go to value field settings, and then I'm going to change it to average. Click OK, and zoom in a little bit so you guys can see. So what we're looking at now in this pivot table is the average hospital days per decedent in each state. So we're going to say, so it looks like California has 10.67, Florida 11.798, and so on and so forth. So these are the average hospital days per decedent for each state. Again, you're going to probably have more states and slightly different numbers when you do this because I'm using a short version of the data set. So once you've done this, you're going to go back to your template. And we have this column here that says, does variable of interest change based on explanatory variables? So what you want to look at is take your pivot table and see does there appear to be a relationship between these two variables? And if the numbers are all pretty close together, then you'd say, no, it doesn't change, there doesn't appear to be a relationship. If the numbers are different, then you might say yes. Now, one thing I really want to highlight about this activity is this is just to get you used to looking at data and looking at cross tabulations. You might say, okay, well, California has 10 and Florida has 11. 10 and 11, I don't know, is that enough to be substantially different, or is that basically the same? For this assignment, you're really just going to eyeball it. It's going to be subjective. As we get further into the semester, we're going to learn to run different tests on your data where you will determine conclusively, are 10 and 11 significantly different enough that we can say there's a true difference there? Or are they too similar and that difference is just due to random chance? That is what we're going to be learning later in the semester. So for this assignment, you're just eyeballing it and you're saying it looks like there's a relationship or it looks like there isn't a relationship. You haven't yet learned, unless you've taken other stats classes, you haven't yet learned how to determine if there is a true relationship there. So this is just like subjective interpretation. So at this point, there's not going to be hard, correct, or incorrect answers. This is just getting you used to looking at the data. Now, what I did here was I demonstrated how to run a pivot table for a hypothesis where you're using a categorical variable as your explanatory variable. Your outcome variable, if you're assuming you're using hospital days per decedent, is pretty much always going to be a quantitative variable, so we don't need to differentiate there. But you may have some explanatory variables that are quantitative and some that are categorical. So this is how you run a pivot table for a categorical variable. Now, let's say for my second hypothesis, is that hospitals with higher numbers of hospital beds have higher days per decedent. How would I do that? So I'm going to go back, and so that's going to, hospital beds in this particular data set is, where is it? Hospital beds is a quantitative variable, as we can see here, right? This is numbers. So in order to run a pivot table for a quantitative variable as your explanatory variable, there's a couple of extra steps you need to take. So just like I did, I'm going to start by doing the same steps I did with state where state was a categorical variable. I'm going to highlight up to the variable I'm using. Again, you can highlight the whole data set as long as the columns that you need are in the highlight, that works. I'm going to go to insert pivot table. So I'm going to put, so just like before, remember the explanatory variable or independent variable goes in rows, and the outcome variable or dependent variable goes into values. Just like before, I'm going to click the drop down because it defaults to sum, go to value field settings, change it to average. Great. Now, at first glance, this pivot table is not very useful, right? It basically has each row, it appears to be like one hospital, so it's not really summarizing anything. So we're going to bin this into either high and low or high, medium, and low so that we have some real summaries here and not just a bunch of numbers. So our rows are going to be hospital beds. And then each value within the row is hospital days per decedent. So what we're going to want to do is we're going to want to group hospital beds into high, medium, and low, or high and low. The specifics are kind of up to you. In my case, I'm going to group it into high, medium, and low. And it's kind of up to you how you want to establish what cut points to use. I'm going to use the 33rd and 66th percentiles. So I'm first gonna go back into the actual data. And where you can do this directly in the data, I'm gonna just paste it into a new tab so that I don't mess up the data too much. But I'm gonna highlight the hospital beds column, copy it, go to a new tab, paste it, and then I'm gonna find the 33rd and 66th percentiles. So for 33rd, I'm gonna do equals percentile.exe. Array is gonna be just, the data. So I highlight that. And then for K, I'm going to do 0.33. And then I'm just going to copy this and change it in the text. Sorry, I'll make it bigger for you. So now we have the same syntax, percentile.exe, but now I'm just going to change 0.33 to 0.66. So I'm calculating the 33rd and 66th percentiles. So what this means is, and again, this is how I'm choosing to bin the hospital beds variable, but if you have a different method in mind, there's not really a right or wrong. If you don't know what to do, then just do what I'm doing here. So I'm going to say that any hospital with less than 45.5 beds is going to be in the low group. I'm going to say any hospital that has between 45.5 and 54.0 is going to be medium. And then anything above 54, I'm going to call high. So these are my cut points I'm going to use. So to do this, I'm going to right click in any data point that's in that first column. We're going to right click. I'm going to click group. And then it defaults to the lowest number and the highest number, and by it gives you 10. So I'm going to click that, see how it looks, and then we can adjust this and play around as needed. Okay, so first thing I'm going to do, I realize this gives you really ugly decimals, so I'm going to just start by changing it from 25 to 91 instead of the big ugly decimals, and it groups it by 10. So this gives you, let's see, 1, 2, 3. This gives you kind of a lot of categories. So now I'm gonna go back. I'm gonna right click a data point in the first column again, click group again. Let's see if we can get it into fewer categories by 20. Great. I'm actually gonna do it one more time because I want to try to get it to like 3 or 4 categories. So I'm going to group it by 25. Okay, great. So what we end up with here, we have, I'm not really going to consider this first row because there's no hospitals in it, but we have 25 to 50, 50 to 75, and 75 to 100. So what this means is that the average, actually wait, let me make this bigger so you can see. What this means is that the average hospital days per decedent among hospitals with 25 to 50 beds is 9.24 roughly. The average hospital days per decedent for hospitals with 50 to 75 beds is 12.2 roughly. And then for 75 to 100 beds, 16.55. So once you've made this pivot table, you can either keep the ranges, or you can overwrite it to say low, medium, and high. And what you're going to want to look for, so going back to the template that you're going to be filling in here, does variable of interest change based on explanatory variables? You're going to want to see, is hospital days increasing alongside the hospital beds? So if there's a positive linear relationship, if, for example, hospitals with higher numbers of beds tend to have higher days per decedent, then we would expect to see this number go up alongside low, medium, and high, which in this case appears to be happening. If there's an inverse relationship, then we would expect to see this number go down. So we would expect low to have the highest number of days per decedent and high to have the smallest. And if there's no relationship, then we would kind of expect the numbers to be either all very close to each other or all over the place and not in any particular pattern. So let's recap what you're actually doing here. You would be making a hypothesis, and your hypothesis might be something like hospitals with higher numbers of hospital beds tend to have higher numbers of days per decedent on average, or hospitals with lower numbers of beds have higher days per decedent on average. Something like that would be a hypothesis you would make. Then you would go and you're going to make the pivot table like we just did. And you're going to look at the numbers and you're going to see, are the patterns that we expect emerging based on the hypothesis I've made? If there is a pattern and it's in line with your hypothesis, then in this column here, does variable of interest change based on explanatory variables? You're going to say, yes, as whatever explanatory variable increased, the other one also increased, just like I hypothesized. If there was a pattern, but it's the opposite of what you hypothesized, you could say something like, there is a pattern, but it was in the opposite direction of the hypothesis. And if there's no pattern, then you would just say, there didn't appear to be a relationship between these two variables. So you're going to want to do that you're going to want to make 4 hypotheses, and you're going to want to make pivot tables for all of them. And now one thing I haven't been doing, you are going to kind of want to clean up your pivot tables so that they make sense. So I would change, by default, your pivot tables are going to say row labels. I would change that to the name of your explanatory variable. So in this case, I'm going to say hospital beds, or like average hospital beds or something like that. And then you're going to want to make a title for your pivot table that just explains what it's showing. So in this case, I might say hospital days per decedent grouped by hospital beds. And you can, there's some flexibility with how you want to name it, but if you're not sure how to name it, just follow my syntax here, and that should be fine. And then you're going to want to make sure that you paste your pivot table into your template before you hand it in. So I would actually start out by saying, I'm just going to pretend right now that pivot table went with my hypothesis 1, but you'll want to do it with the relevant hypothesis. Oops. I'm going to copy that and paste it into the template, because your professor is going to need to see your pivot tables in addition to your hypotheses. And that is check-in 2.